Okay, let's start with the problem for our Truss only. Okay, so for that, I'm summarizing the data here. Calculation of wind load. Bhubaneswar. So once you mention the city, then from Annex A, BB equals to so Annex A, BB equals to for BB. This is alphabetical. This is alphabetical. So you can take B. So for Bhubaneswar it is 50. 50, what is the unit? 50 meter per second. So BB equals to 50 meter per second. Okay. So one more thing you can get that Bhubaneswar is within. Bhubaneswar is typically you can take or not take also. They told for cyclonic region up to 70 kilometers. How many? So the effect of cyclonic storm is largely felt in a belt of approximately 60 kilometer width at the coast. So Bhubaneswar is around 70 kilometers from sea, but that means you can think about not think also. But always whether the options are there, as a designer, you should take the worst case. Okay. This is the concept or philosophy of design. Whether you have the option of two things, then worst thing you should always take. Okay. So in our case, it is 60, so we can consider it as a cyclonic zone. Okay. Okay, so till now it's fine. Any other different information? Spacing. Spacing of truss equals to 5 meter. Okay. Okay, so these are the accumulated data. Now start with your calculations. First, basic wind speed VV equals to 50 meter per second. Then what is the term? Design wind speed. Designed wind speed bracket VZ equals to VV into K1 into K2 into K3 into K4. Okay. Um, Table 1 of IS 875 2015. So let's see. Table 1. So for general building and structure, then temporary shed, building and structure presenting low degree of hazard. So which one you consider? As I told, you can take number 1 or number 3. So you'll take 3. That is your learning for 25 years. Okay. So our basic speed is 50. So 50 is number 8, column number 8. So considering structure presenting a low degree of hazard. Okay. So 0.9. Considering low degree of hazard for life, value of K1 corresponding to BB equals to 50 meter per second equals to so K1 is done. Now for K2, you have to need to find out two things. That is your terrain category and your height of the building. Okay. So terrain category of the proposed structure, category 3 or 3, category 3. Total height of the structure, yeah, 6, 7.5 already given a 7.5 meter. Okay, so from table number 2 corresponding to category 3 and since the structure height is less than 10 meter, consider the value or 10 meter in table 2. Okay, now go to table 2. So table 2 category 3 and 10 meter height, the value is 0.91, right? In category 3 up to height 10 meter, the value is 0.91. So I have to take 0.91. So K2 equals to 0.91. Okay. Then since the locality topography of the locality is plain, that is less than 3-degree slope. K3 equals to 1. Okay. Now, considering cyclonic region, then what type of structure you take? The structures of post-cyclonic importance for emergency services such as cyclonic centers, hospitals, school, communication tower, etc. So this is not our case. Industrial structure or other structure. So you can consider it as industrial structure or other structures. I think as per my principle, as I told, whenever the two options are there, you can go for the worst one. So you can take 1.15. Okay. And industrial structure K4 equals to how much? 1.15. So done. So I have calculated K1, K2, K3, K4. Okay. So now your Vz equals to Vv into K1 into K2 into K3 into K4. That is equals to Vz equals to 50 into K1 is 0.9, then K2 is 0.91, then K3 is 1, and K4 is 1.15. So how much is value?
47.0925.
47.0925. So we are getting less than the basic wind speed because our structure is not so important we have considered. Okay, see, except the cyclonic part, other cases we have got the lesser value than 1. Height of the structure ratio and the risk factor both we got less than 1. That's why our structure can be designed less than the 50 meter per second. Okay. So up to this is done. Next is your PZ. PZ equals to 0.6 into Vz to the power Vz square. Unit is in Newton per meter square. Carefully you think about that. See, wind pressure at height Z in Newton per meter square. Okay, this is very important. And Vz will be in wind speed at meter per second. So these units are very, very important. So don't get confused. So Newton per meter square. Okay. So in our case, Pz equals to 0.6 into 47.0925 square. What is the value? 1330.2 Newton per meter square. That is almost 1.33 kilometer per meter square. Okay. So done. Now your PD will be your PD equals to Pz into Ka capital into KD into KC. Okay. Now go to KD. KD के लिए yes. Clause number 7.2.1. Okay. So value is for triangular. For triangular, a factor of 0.9 may be used on design speech. For circular, non-circular, for this category, you can take 1. And for circular factor, you can take 1. So our case, it is 1. Okay. So clause number is 7.2.1. According to clause number 7.2.1 IS 875-2015, considering cyclonic region. So KD equals to 1. Clear? Then KD के बाद K. K. So you have to calculate the tributary area. Nine meter into how much span? 5 meter, na? 5 meter. That is 45 meter square. Okay. So clause table number. So here also we'll take 45. So for 25 it is how much? For 25 it is 0.9. And for 100 is 0.8. So you have to interpolate between 0.9 and 0.8. Okay. From table number 4. So K corresponding to 45 meter square equals to, so it will be less or less 0.9 minus, how to calculate? 0.9 minus 0.8 into, बोलो कैसे होगा ये? 0.25 25 के लिए 0.9, 100 के लिए 0.8. So these divided by these into, so 0.9 से कटा ना तो 45 minus this होगा. Okay. 45 minus 25 divided by 100 minus 25. So what is all of this? 0.827.
0.8733.
This is the estimate because see up to 25 to 50 ना, तो 75 meters के लिए इतना हो रहा है. So 37.55 जो होगा तो it will be 0.85. उससे भी कम होगा 20 है ना. So it's fine. This is fine. Okay. So K equals to 0.8733. Okay. Now for KC, I told I have to go to page number 16. Page number 16. Yeah. So page number 16. So the value is 0.9. Okay. 7.3.3.13. 7.3.3.13. So Kc equals to 0.9. Okay, so all these coefficients we have calculated. Now PD. PD equals to Pz into Kd into Ka into Kc. Then PD equals to 1330 bolo 1330.62 na? Hello?
Yes, sir.
62
हाँ sir.
into KD कितना है 1
KD1
into Ka 0.8733 into Kc is 0.9. So finally, how much you are getting hello PD? 5.83 unit Newton per meter square. Okay, so that is the biggest part you have already done. So calculate KD. Okay, then your so capital A equals to your 9 meter 9 into 5. That is equals to 45 meters square. So 2 3 have done. Now we have to calculate CPE by CPI. Now tell me, what is the values of your opinion? What you want? You want the small ventilators above, or you want to look at the go down? बोलो मैं तो क्या कहूँ, what is the purpose of my go down? Weight ना, so weight store करने के लिए तो ventilator चाहिए. How much thing you want to take per pitch, per spacing one? So you have to devise some ventilation systems, either ventilator, then windows and door.
Yes, sir.
How you want to put the ventilation system for you for this? पहले एक 5 मीटर ना, 5 मीटर में 5 मीटर मतलब 15 फीट, तो 2 वेंटिलेटर चाहिए मुझे है ना. So एक स्पेसिंग में 2 वेंटिलेटर मीन्स 2 + 2 4 + 2, so it is 8. 8 means 8 into 2, 8 into 2 into 2, so 8 into 2 16 into 32, so 32 numbers of ventilators of size say your 300 to 300 or 500 to 500. I think let's say 300 to 400. Let's say 400 to 400. Okay. So do you want to provide any window? The window is not required. Well, I think door windows, let's negate it. So door will be there. There will be around 4 meter height and 3 meter width. So 3 by 4 in the height of the opening. So let's see. So considering 2 ventilators of size 0.4 meter into 0.4 meter in each spacing of each 5 meter spacing, or 5 meters for each 5 meter panel. And a front door of size 3 meter into 4 meter. Total opening area equals to, so 860 na, so total is 8 points are there, so 8 into 2 into 2. Oh, this side also na, so we are spanning this side or this part. the bottom, sorry, the back side. Back side you want to provide, you're going to ventilators. Back side, I think I'm sorry, plus let's say 3 is there. 9 meter, na? So 5 meter में 3 plus 4. 4 दे देते हैं. So this is the total number. Into 0.4 into 0.4 plus 4 into 3. So anyone has a doubt about this? So I'm showing the diagram again. So I have provided one door here. Okay. उसका height है 4 meter, width is 3 meter. Okay. And then I provided 2 ventilators at each spacing here, like this. The wall, vertically, not horizontal. This I'm showing the plan, but it is in the horizontal one. That means there will be door there. Let's say this is your wall. This is your wall. This height is your 6 meter. Okay. And this is your 40 meter. Okay. Now each 5 meter interval truss is there. Okay. So we are putting each 5 meter में दोनों करके. Here also 2. Then like that you have 8 spacing. This is your truss. Okay, like this you have 8 trusses there. And then I told that you have to put the ventilator in the back side also. Here also I told I want to put 4 ventilators. And this side 1 door. Now understood. So this is 8 into 2, 8 into 2. Okay, this is your 2 long sides. And this is your back ends, 4 numbers. So that's why I did 8 into 2 into 2. This is for the 2 longer sides. And then plus 4 is for the back side. And this is for the door. So this is the total area of your opening. Sorry, the value? Actually, this will not come here. This diagram is wrong because if you are showing the elevation, it will not come here. If you take the side view, they will come here. How much value? 17.76 meter square. Okay. Now, total area of the wall. Dimension is in front of you only. So span is your 9 meter. So wall area will be height into length. So 2 into bracket 40 plus 9. This is a perimeter into height is 6 meter. So total percentage opening equals to 17.76 by 588. Into 100. How much? 3.02%. So you have taken very less opening. So less than 5%. So you have taken very less opening. That's why it becomes 3% only. Because we are not considering any windows. So if you consider any windows, then definitely this will increase. Okay. So based on this, you go to yes. 7.3.2.1. Okay. 2 different images. In case the building's cladding permits for where with opening not more than about 5%, the wall, so 7.3.2.1. Okay. So according to clause number